And I also would like to welcome all the people here, but also the journalists who we have specifically invited for this event. Part of them are connected remotely. We've got a YouTube channel that is live broadcasting this session. We've also got some members from our national working group who are remotely connected, because unfortunately they could not be with us in person. Part of our presentation concerns the white book, the white paper, as you know, and it's actually is going to enable a lot of people to participate in the discussions. Let me introduce Mrs. LUU-VAN-LANG, who will be co-moderating this session. I'll try and be as good as she is in moderating. Let's start off the first set of presentations. Mrs. LUU-VAN-LANG will present them. We'll have two parts in this conference. We'll start off with the first session. We will be welcoming with Robert Rook, major players, Paulo Fernandez, who's an industrial engineer and is responsible for VEOLIA for this subject, and Safwan, is responsible for ANI for SUEZ. Quick overview of the program. Can you take your seats, please, and take a mic as well? We've got three sets, three parts. I will be briefly introducing the technology, and then I'll come back to the white paper. We've got our testimonies of the main players in waste recovery and waste reusage. We clearly have asked people to focus on this subject, and we've got another roundtable, another panel session called Offer. They will be welcoming different stakeholders in terms of the development of this technology. We've got the honor of welcoming an American representative, Mr. Jim Euler, who's being willing to be present here, and then afterwards we will be listening to some customers, industrial customers, but also local authorities here, which will be showing their interest in this technology. Thank you, Robert, for this introduction. Starting off with the first set, Robert, you work for GRTgaz, and you're the moderator for the national group. Can you talk to us about this subject, and in particular about the white paper? Sorry. Before we start off talking about the white paper, which you can find in detail the presentation of this technology and its main benefits. Let me briefly explain how it works. The specificity of this technology is to actually use entrance here feed stock organic waste, which can be more or less dry or even in liquid form. The essence is, what's the most important is for them to be pumpable. Either we add water or the water comes along with the feedstock. Water is extremely important because it's the fluid that has the process become functional, and we use this fluid, which we use in supercritical conditions, high pressure and relatively high temperatures. It's going to enable to convert in a spectacular way carbon into methane. At least partly into methane. We can also recover what can be recycled, mineral components, metals, nitrogen, and also water, if there's a lot of it. Now, before we move on to the detail, you take an organic waste, either by itself or in a mix, and then you go via a high pressure pump, which is going to increase the pressure, going to be up to 210, 250 bars, and then with a temperature which is up to 360 degrees, 350 degrees Celsius, you reach supercritical conditions, and that's where the miracle of the process takes place. Initially, we're going to use it in our salt separators, which have become an equipment before the gasifier. The idea is to separate the inorganic parts from the rest here. Then we separate the minerals from the metals, and with the fluid, which is carbon here with the remainder, we go into the gasifier, and then we perform this conversion, which we are targeting to come up with a gas here, high level of hydrogen here, and either we have catalysis or high temperature, and then we can generate two types of syn-gas compositions, which are actually shown on this slide. I'm not going to detail things here, but we obviously are here with the developers afterwards to answer any questions you may have. To recover the gas, we separate what we call the gas to liquid. On one side, we get the high pressure gas, which we can recover or methanize it to make it injectable into the network. On the other side, we recover a liquid, which is water with nitrogen. We can directly be reused, or sometimes we have to filter it, and then we can make it available to industry for various purposes here. I think that's it in a nutshell. I don't want to spend too much time on that. I think here you've got an assembly of families of feedstock biomasses which can be reused and recycled using this technology, but also fossil waste that still exists, which is still present, which need treatment and high performance treatments in particular. There are industrial players in the plastic or microplastic sector, but also in the oil sector. As you can see on the chart on the right here, this technology is integrated within this circular economy approach. We're trying to maximize the recycling and reuse. The final goal is to have as much as possible zero final waste, and to value whatever can be valued, recycle or reuse what can be, and to get rid of anything that may be harmful, in particular bacteria, viruses and other pathogens. In terms of the benefits of this technology, beyond those I've already mentioned, I won't spend too much. The conversion rate is extremely high, between 85 and 99%. We're close to perfection for certain feedstocks. We got the definite need. We don't need much land here compared to methanization. It's 10 times less footprint we need here. Compact, it's modular. Why is it modular? Because we're looking at high pressures here for different reasons. We have to limit the size, and we have a modular approach here. Sizes for 5 tons per hour maximum. The need for treatment, if it goes beyond that, we had a second or even third module. The energy yield is extremely high. In most cases, we're between 75 and 85%, which is excellent performance for this kind of conversion technology. And we've also if we take the DHC and the life cycle analysis, is very positive here. That's what we see in literature anyway. But we're going to further improve things to make sure that we can use it in a very tangible and concrete way. And the last point is the sound and smell here. Nothing makes any particular noise. It's just the pumps. So it's quite silent as technology here, and we can very easily insulate it here, and there's no particular smell. The last point is a lot of financial and economic interest. Obviously, with the gas, we're generating significant added value. But that's not all. We can obviously inject it into the network, and we can stock it. And in France, fortunately, we've got an infrastructure which is pretty good to be able to compensate the variation between consumption and production. We've also got other additional aspects which we need to mention, the link to the service, link to the processing of the waste, and the use of this waste. And then potentially we can reuse all of these other elements and byproducts, which means we have a great added value as far as this technology is concerned. And we've got additional revenue that can come by getting rid of or reducing at least certain costs that no longer exist or which are strongly reduced. And then, sorry, I haven't finished, I haven't quite finished here. This is quite crucial here now today. I made this mistake, sorry about that. I don't know if we've got any copies of this white paper. If not, it would be good to bring a copy here and show it to you. There we go. Thank you very much for that. Today, we've got this white paper has just today been published. It's a first in as far as this industry is concerned and this technology. We try to document things and to publish everything we know about this technology and this industry, which has been available already in many other countries in Europe and now has been published for France. And we clearly want to develop it in France. That's really the work of the many stockholders that are present in this working group. You can see all the logos on the right here. The birth of this idea came from the working group. And the working group, within the working group, we rapidly realized that if we really want all the relevant information pertaining to this technology, you have to look for it all over the place. You have to consult a lot of players, a lot of stakeholders, because there aren't any existing documents that have clearly formalized things. And that's where we thought, well, we need to get on track here to all together, be together, draft everything we know about. There are co-authors and many contributors here who are present today to this conference, and they can bear witness to this situation here. We worked on many aspects regarding this technology. We tried to harness everything we know here to, for example, work on the positive outcome output linked to this technology. We considered it from an environmental, economical, emission point of view. And there are a couple of elements you can find within this white paper. There we go. Today, this white paper, and that's a first as well, will be available on our website of GreenGaz, free access. You have to follow out for but it's very short. It's just to see who's interested in this technology. It's important for us to know who's interested in this technology. Is it more customers? Is it more users, etc.? Are we talking about institutional or officials here or local governments here? It's not too detailed either. Obviously, we have to limit ourselves, but you'll rapidly understand everything that pertains to this technology in terms of the possibilities and opportunities we've identified for France. It's not totally comprehensive, but it gives an idea of the potential in terms of production we are targeting and which we consider is possible between now and 2030 and 2050, how this technology can be integrated within the local and regional areas, and it can take place with the public and private stakeholders. We worked on the first business cases. Obviously, if it is not viable from a financial and or economic point of view, obviously all our efforts will not succeed. Obviously, the stakeholders want to make a living, and that's important. Now, it's also partly linked to what is available. Everything, every the content is different in terms of the actual feedstock here. It depends on here. We can have business models that can be quite different depending on the feedstock. Sometimes it may take more time, sometimes less time. And to ensure the emergence and the success of the projects, we're going to sometimes have to merge certain feedstocks here. Just coming back to a point here, Robert, sorry, I'm the timekeeper. You're running a bit late here. Yes, it's true, I'm a bit too talkative, so I'll try and stop there. I just wanted to present the key authors who are worked with GreenGaz. We've got Serima. They worked on this model here. I'd like to thank the people from Saint-Nazaire, but this gather did a great job from that point of view. And obviously the various other people who you can actually see that they're all present today. And you can present questions to them. And then the last point is the roadmap which we want to create. We can see the different stakeholders. We've got the CA, Covansi, we've got the LLT, they're all present here. They clearly represent the startup of this new industry in France with ambitious goals. We want to have not just the demonstrators and pilot projects in place, but as of 2026, we clearly want to make this operational from an industrial point of view with a significant goal for 2030. And this is quite a challenge here, what we're talking about. We're ready to face it here. We're talking about steam systems here, and we want to, in 2030, to reach a significant level in terms of production, as you can see on the chart here. To succeed in here, we need public authorities. Here we need specific support as far as developers is concerned, so we can accelerate things. They need means and resources, in particular human resources. Then people, most of the stakeholders who are small, country present, are small companies. They're very innovative, but they can't do everything themselves. Here they sometimes need support, just like their colleagues abroad. It's important for us to be able to provide that support. And for the first project, for those who are willing to take a risk, the idea is to have support from the various ministries and other governmental authorities here. And then finally, we also need a regulatory framework here which enables to put in place these projects and make sure that we have a certain homogeneity throughout the country. Yeah, I'll stop there. Thank you very much for this nice introduction. And thank you to all the contributors who prepared this white paper. This technology has many technologies, has many advantages. You're producing energy, but also you can reduce and ensure heat recovery. You participated to this white paper. Now, when we talk about hydrothermal gasification, can you explain that? I think it's pretty clear why we decided to participate to this promise. Well, we've got a goal. We have to save energy. We need to reduce our energy consumption by 5%. We're talking about increasing our energy production by 5%, and all that within 2 years. So the impact will be 10% beyond energy. The environment is important as well. Now we're in France, because we're in France, but in fact, we are targeting in the same way to focus on having the necessary services we can provide to local governments and to industrial companies, and that will be the case within 5 years. Practically 100% local energy. It has to belong to the area and region. 80% renewable with a solar contribution and circular 75%. You can clearly see that through the various challenges, which are challenges, today's challenges, not tomorrow's challenges. So this technology ticks all the boxes, and I hope it's going to emerge in a positive way. If I focus a bit more on VEOLIA, the example of VEOLIA in France, It's work on this hub energy, to work on the territories, the areas, geographic areas, work out our clients, work with the producers and bring together within a single point, which we've called the energy hub. The idea is to bring the ability to produce energy locally and to be able to value those resources that are available. If I come back here and go into a bit more detail, we're talking about these key challenges in terms of this sector we participating to this target, which is net zero, contribute to net zero. VEOLIA has clearly signed up for this. We've already got an offer, but once again, we can clearly say that hydrothermal gasification, so HD, clearly ticks all boxes here. VEOLIA clearly wants to target recycling, the recycling of organic material and also fertilizers. And then afterwards, when it is possible to recycle, then we can consider thermal recovery here or reuse. That's incineration. That's something we would like to avoid. But we can do, because we can recover the heat. And if you take the HG, we can clearly see it represents the hierarchy. We're going to produce gas, we're going to produce minerals, we're going to produce material, which will be fully within this hierarchy. In this description, we've got a process, as the title says, it's full of promise here, and it's going to enable us to generate revenue, generate services, and have a geographic approach, and with scalability, small, medium, and big here. Now, the contribution, our contribution to the HG, we got together with the public authorities here and local government here. Now, I have communicated this to my colleagues, but at last I can communicate and share it with everybody. This is the kind of foundation of what we want to do now and in the future. Obviously, everybody's got different visions. The matrix to grid isn't quite the same for everybody. VEOLIA's contribution and all the people around the table for this white paper. The TTH is what Robert said. We need references here. We need to fully control the technology. We need to focus on its availability and its economic and financial performance here. For VEOLIA, we need to be capable of providing our opinion and to come up with a demonstrator for these technologies. And we need to share with you. We've already shared a lot of efforts have been made with Robert. We need to share with the users, clients, public authorities, whatever, provide a regulatory, technical framework as well here, and also financial framework here. As I said, full of promise, and that is clearly what we're trying to develop. Thank you very much, Paulo. Safwan, AYOUBI, you developed the concept of a biofactory, and can you explain what we are actually talking about and how it fits with what we have just previously said here? Well, thank you very much, Laura, for presenting SUEZ's star, which is the biofactory. Biofactory is just a unit or a plant that enables the whole government to have resources and produce renewable energy here. That's why it's called STAR, which you can actually see on the slide here. It's a first step in terms of a solution that fits within a circular economy solution. As an example, on this drawing, it's in the case of wastewater management here, and where we're talking about recovering the essential resources, which is water that can be reused, and also the nutrients that can be separated. We've already got solutions that separate phosphorus from water, but that is something that needs to be further worked on. And also the biomaterials, and especially the biogas here, biomethane as renewable energy. To give you a bit of a figure, some figures here, if we consider the urban treatment centres, SUEZ produces already 50% of biomethane. Within this momentum, in terms of recovering and reusing and hydrothermal gasification. Well, this is a definite promise as mentioned by Paulo here. but it clearly fits within this overall approach. We've got a perfect adequation and match with SUEZ's strategy in terms of this approach of recovering and reusing resources. The promise is to have a solution that fully fits within a future biofactory 2.0. The integration of this solution always within the example of the treatment of wastewater that will enable better valuing of organic matter, reuse and recycling, and where we can double the amount of renewable energy production. We'll be able to also recover the nutrients in a way that will be much easier to use and reuse and to sell afterwards. Thank you very much. You also are a member of this natural group, and you also contributed to the white paper. Why? Well, for all the reasons I just mentioned here, SUEZ was involved in this working group. I'd like to thank all the work that was performed by Robert and his team and the other people to be able to come with this great outcome, which is the white paper, and all the other work performed by the work group. The white paper is the first deliverable here of this working group. And in this slide, I'd like to insist on 2 points that you can actually find in the white paper. And I always like to take the example of sludge treatment here. The development of this market clearly shows that the current solutions are facing issues in terms of acceptance and acceptability, and also facing more restrictive regulatory frameworks to avoid pollution and environmental impairment here. Now, as presented within the white paper and also within the discourse of Robert, hydrothermal gasification is the possible answer to this issue and can solve issues such as pathogens, micropollutants that can be found in water, but also a possible coming back, making sure that the nutrients can go back to the soil here, and that can be better streamlined and better optimized, and the control of the environmental footprint here. The second goal here is to actually be able to support this new innovative technology and to move it on towards a sustainable sector. We need a regulatory framework that's going to enable to make decisions, to build and to come up with operations, and this in the best possible situations and in an acceptable time frame. Second mechanism that will accelerate and drive these projects that will enable the creation of new industries and new sectors, and those are the financial approaches, funding, fundraising, etc., ways to support these projects here. Now, SUEZ, with the working group, is ready to move forward here with the various local governments and other public authorities here. Thank you very much. We've got time to take one question. If one of you has got a question in the audience, even though the first question is always the most difficult one to raise or to ask. Anybody? No? Well, in that case, thank you. We can move on to the second roundtable, which is focusing on technology. And we've got a special from the United States.
He is the founder of the Genifuel Society company, and well, Genifuel is a society, a company, that is developing a hydrogen gasification unit in cooperation with the VALLEJO. So we have here Chevaux as well. We will have Sofiane, ZALOUK and Javier Vallejo for the technology. They are responsible, the R&D responsible manager and commercial manager. We will have Frederic JUILLARD. He's the president of TreaTech. They are working on technology and he has a team of 10 people. And Frederic, he is the responsible for the circular carbon economy strategy, and he's working in hydrothermal gasification as well. So we are going to start with the first question that will be asked to Thomas Chevaux from INSEE Environment. You are doing like a collaboration with GreenGaz. So what are the advantages for both parts? Hello everyone, and thank you. Thank you for this invitation. Okay, maybe I will show you some images. Okay, no, is it working? Okay, there it is. Okay, maybe we can go back to the previous one, the previous slide, please. No, maybe it's not working. Okay, in our company, well, we have been working for a few years. We have a 50 years of experience. Well, sorry, my slide is not showing properly. So we have 50 years of experience in waste treatment engineering, and we mainly concentrate in the field of gas. VANCI Environnement is the engineering company that wants to offer different services. As a constructors, we want to go more into GreenGaz. So we've been very aware of what were the progresses that were made in this field. And after having worked in a partnership that was called PAMETA, we were able to show that this hydrothermal gasification process is very positive in general. So we tried to see how we could keep on making progresses. So nowadays we've met GreenGaz. They are present here. We have James Euler here. I will give the floor to him in a few minutes. So we decided to work together. VANCI is working as the integrator, the design of turnkey plants, and in order to see all the process related to the preparation of the feedstock. And the idea is that we could treat all these products. And GreenGaz will help us regarding liquefaction and gasification. So GreenGaz is a company that has been working for many years in this field, and they will have the floor later. But we thought that this partnership would bring us, would give us the opportunity of accelerating our development, because we had a certain maturity in the field. Thank you very much, Mr. Chevaux. You have, Mr. Euler, you have developed many different projects. What are the main successes of the project?
Okay, thank you and good afternoon. What we've been doing, we've been working on this project and this technology since 2006. And we started with a partnership with the U.S. Department of Energy through one of the national laboratories in the state of Washington, where this technology had been developed starting in 1970 and extending through to today. GreenGaz began working in 2010 with the laboratory in the development of both oil and gas technology, so hydrothermal liquefaction and hydrothermal gasification. Most of the work during that time was in fact in gasification, hydrothermal gasification. And so that technology and all of the development that went on has now been licensed to Genefuel for commercialization. And we began developing scaled up versions starting in 2010, and we have built several systems, each one larger than the one before. This one shown on the right here was developed and delivered to India for operation by Reliance Industries in India for processing algae into liquid fuel and also gas. So that system has been running now since 5 years, 6 years almost in India, and has been very successful. They have not run it continuously, but they process primarily algae in the season as it grows. So it has been running when they had the feedstock. In addition, since that time, we've built several other systems. One of them, which has been very useful, is a mobile system that can be moved from place to place. So it has been operating in multiple locations, primarily for the processing of wastewater sludge. So we have processed wastewater sludge in multiple cities, first in California, then in Oregon, and then most recently in Florida, with several cities, Orlando, and a smaller city just north of there. We can move this from place to place to demonstrate with different processes, different wastewater processes, and different types of sludge. So we have a scaled up system that we built for India, and then a smaller system that we built that can be moved from place to place. The next process or project that we've been working on is also wastewater, and this is for the city of Vancouver in Canada. And it's at one of their large plants. Vancouver has a population of just under 3 million people. There's 5 plants that provide the processing for that population, and we are at this one shown on the left, which is serves a population of about 25% of the city. We will not be doing all of that. We will do a portion of that flow in order to provide data for the city to implement this throughout all 5 of the treatment plants. And that project will extend through the year 2036. It's part of a large strategy to upgrade the entire system to hydrothermal processing. So this has many advantages that we have developed for both the hydrothermal liquefaction and hydrothermal gasification. And I'm going to give this back to Thomas because this is a very busy slide and it's easier for him to do this in French.
Bon, je vais être soulagé, donc effectivement, en français parce que ça va être plus compliqué. Donc Jim voulait aujourd'hui à son actif.
I wanted to say that we have tested almost 70 feedstocks that were tested. Maybe I can give you the list that interests you. So the idea is that we've made all those tests, and we have seen that it produces 80% more methane than other elements like methanization. So this will allow us to have a best price, and it contributes to multiple environmental and climate targets. We are trying to remove or to treat some difficult compounds like PFA.
Système donc évolutif. Alors le design aujourd'hui il est
So
modulaire, ça permet d'adapter la capacité du
it has
traitement
a modular design,
en fonction du besoin.
so we can adapt the capacity according to the need, as you've seen on the picture, where we have different sizes, different modules, so these can be made on site. So the OPEX cost is being evaluated, but it seems to be quite optimal. And we think that it could be interesting for the international market, but because this technology can be used anywhere in the world.
So now we pass the microphone.
It's just a question about the PFAS.
Donc une petite question.
Oh, the PFAS. These are organic chemicals which have been manufactured for most of the 20th and 21st centuries. It's used in all kinds of applications. There's thousands of these chemicals, but the primary quality of these chemicals is that they're very, very stable. And they do not break down, they do not decompose in the environment. Once they're in the environment, they really last forever. And one of the applications of these is in treatments for fabrics, clothing, furniture, and so forth for protection from stains. And they're used throughout the world. But as these fabrics wear or are washed, the chemicals get into the wastewater. And the wastewater treatment does not destroy them, so they build up. And as these wastewater sludges are disposed of, they remain in the environment. So this is a problem, and now we are concerned with how do we treat the wastewater so that the chemicals are removed or destroyed and do not get into the environment. This process, the hydrothermal treatment, the gasification process and the gasification catalyst destroy these chemicals. So it is a treatment which can be part of the overall processing of wastewater sludge, but with the added advantage of removing these forever very stable chemicals. And this will be published probably within the next year by the U.S. Environmental Protection Agency, who is testing many different treatment methods, which can then be listed and documented as a priority for treatment of wastewater and to prevent these chemicals entering the environment.
Thanks very much. Next, question suivante, Javier Valero. Donc, pour le LOTZ technologie, comment le LOTZ technologie en est arrivé à se positionner sur la gasification?
So how you are thinking about how you are positioning yourself in this kind of situation? Yes, it was quite natural for us. So the idea to concentrate into hydrothermal gasification, it's a good experience for us. So hydrothermal gasification is a treatment for organic waste. We have another way. We are using hydrothermal gasification with less oxygen, so there are many different conditions that we can have. So the idea is that we are going to learn more about the materials and the processes. So we have also a KIT, so we are developing a European solution in this case. We are located at 15 kilometers from France, but from Strasbourg. So the idea is that we have a laboratory where we have an installation, and we are trying to create a pilot project in this sense, and then after that we could have a bigger facility. I will give the floor to our colleague, Stéphane. So now you are working into the development of the technology. You are working in the Gamma project. So where are you now in terms of technology, and what are the specific facts that you would like to point out? Okay, the Gamma project is a project of industrial demonstration. So the idea is that we would like to treat what is produced at the LEROUX plant.
Aujourd'hui, on est en cours
Nowadays,
d'études d'ingénierie.
we are doing engineering studies. So we are studying the equipment, the reactor, and all that. So, and nowadays, the idea is to continue with this study in order to see how we can improve the price of the demonstrator. So, at the financial aspect, so we want to improve all that by next year, and we will concentrate on this demonstrator. So in 2024, maybe we could do some different tests in this demonstrator. So in order to come back to Robert's question, well, in this case, we have an industrial demonstrator with a high capacity. The idea is to see how we could test two different configurations and to have a facility that will work constantly in a permanent way. And we would like to keep on doing some different tests in order to have an industrial installation. And regarding the technology, well, what kind of family technology sector are you concentrating on? Yes, we are using a high temperature technology. We are concentrated in this kind of technology. This is why we are using different demonstrators, because we already have the demonstrators that will allow us to increase the temperature to reach almost 150 degrees. Thank you very much. We have another question for Frederic. So you have already done a pilot project. So what do you think that will help you to keep on developing this project, and what are you concentrating on? So the idea is that we have 100 kWh that is being built in a partnership. So we have created a different company. Before that, we have made many years that were devoted to research and development. So with the Paul Scherrer Institute, they have a lot of experience regarding this catalytic work. So the IHG at a higher temperature, the hydrothermal gasification at a higher temperature is key for us. So this catalyzer well, has quite a high selectivity. And this will allow us to work at different temperatures. Will give us the opportunity to have catalysis and to see how we can reach the synthesis gas that we would like to have. So there are many different aspects that are key in this sense. We have a pilot project where we can have the opportunity of making loads of tests in order to understand what is happening, what is going on. And we might have a similar pilot project at a different scale. in order to see how it works in the industrial sphere. The idea is that we want to test all that in thousands of hours with feedstocks that are taken from the beginning, and then we can produce gases, etc. Sorry, but the sound is very poor. I don't know what's happening with the sound. Sorry for that. So maybe this unit will be a fixed one or maybe a mobile one? Okay, it has been designed for being a mobile unit, so maybe it can be transported, and well, the objective is to be able to transport it and to bring it to different markets. So we can validate this technology with different feedstocks, as it was presented previously by Jenny Fuel. Okay, so we have Frederic Ducrot representing the CAA, and he will speak about hydrothermal gasification. So where are you working now? What are you exploring in this field? So maybe you could speak a little bit about what you're doing. Thank you. Okay, so we started making some studies with different feedstocks. And, well, feedstocks that could not be transformed or converted into gas. So these were feedstocks that should be reused. So, sorry, the sound is very poor. We cannot receive the same the message. Sorry for that.
Concernant notre roadmap, donc j'ai rappelé sur la partie gauche du graphique les différentes étapes.
Well, on the left, we have the different stages of the production, preparation, injection, separation of salts, and gasification with a high temperature.
D'installation. Nous opérons sur
des different facilities.
Pour nous, un compromis intéressant entre la possibilité
a very interesting engagement because we want to
représentativité. Donc, nous allons pousser des technologies d'injection, de séparation de sel et de gasification mais séparément. En 2024, nous comptons couper l'ensemble de technologies pour se mettre dans une situation complète et réaliste d'une conversion. Ces technologies sont prévues pour être facilement scalables jusqu'à des tailles de 0,5 tonneur.
Et and we have seen the different results we got from studies in 2024 and 2025. So we have different technical results. And to conclude, the idea is that we are going to launch in some thoughts, some different studies in the catalytic approach, HTG. So that's it. Thank you very much. I will finish with the last question that I would like to ask to Thomas. The idea is that, well, I would like to know what is your opinion for the 2030 horizon, how are you expecting to develop the French market in this sense regarding this technology? Okay, our roadmap, well, we've made a small program over the next 10 years. So the idea is that we want to keep on progressing in our partnership with GreenGaz. The idea is that we want to develop pilot projects that, with a similar design that similar to the one we've made in the United States. So we are going to do this kind of technology transfer. This pilot project is going to be available in 2024, and the idea is to do all the feedstock tests regarding the know-how as well. We will keep on working with this industrial demonstrator in 2025, and we will do the commercial development at a larger scale later. So this is our roadmap.
Merci beaucoup.
Thank you very much.
Même question pour Frederic Juillard.
The same question for Frederic Juillard. What are the next steps for the development of this technology after all these successes have presented here? Yes, well, this is a small picture of what we plan to do. By the end of the year, we will have finished this construction of the pilot unit. The idea is that we will start the operation in 2024, the commissioning, and after that the operation. We will try with many wastes, and then after we would concentrate in different wastes. The idea is that we are still working on the design of an industrial unit that will be carried out, and the idea is to have 3 tons per hour, and then after that we will see how it's working. We still have so many aspects to consider, but for the industrial treatment we might achieve it by 2025. Thank you very much. And last question for Sofiane ZALOUK. Okay, what is your roadmap for 2030? What is your priority markets, and how the Gamma project is going to be developed? So this Gamma project, well, the idea is to focus on the industrial demonstrator in 2026. So this will be the first industrial facility that will be created in 2027 with the size of between 4 and 8 tons per hour in order to have a good profitability, and we will be making a second facility before 2030. Thank you very much. So we have time for 2 questions. If there are any questions here, please go ahead. Everything was very clear, I think. Yeah, there is a question here. Yes, I have a question. Well, you never mentioned the price of the gas after when you produce this kind of gas. Will it be competitive, the price of this gas, if we wanted to inject it into the grid? So what would be the price of the gas? Maybe Frederic, you can give an answer, because I think you have made some simulations in order to make some estimations of the price. Oh, okay, I have another question. I think at the beginning you have concentrated your development into many different steps. So last year you were here with the SW system. SW system is concentrating more in the industrial scale. So maybe last year, well, everything has changed since last year. So maybe we could answer also the question that was asked. Yes, in fact, I think that it is important to understand that the cost of production of gas, the unit of of the megawatt hour, yes, the sludges, it's a very big market. Regarding the gas, this is not something that we will produce the largest amount of gas, because in other industries you can produce 2 or 3 times more gas, but the idea is that we can reach production costs that are almost 40 euros of megawatt hour. So it's quite competitive regarding all the technologies that are already present into the market. And regarding sludges, well, it depends on the feedstock. Well, if we can create the more gases can be created with this waste, well, we will see what happened with the rest. Well, with this kind of sludges, we have to incinerate them. So this costs a lot to the incinerator. So we will produce less gases, but the client will be ready to pay more, because we are going to eliminate this kind of sludges. So I think we already mentioned the production costs of gas, and well, I think it might be interesting then. Maybe we can sell it at the market price. Okay, maybe we can sell it at the same market prices if it's okay.
That's more from a strategy and a business point of view. There are various business models out there. One of the interesting business models is to provide service. If you want to provide a service, we have to fund our own equipment. And if you've got partners who can buy our gas, and if we define stable and fixed prices, that will enable us to finance our equipment, to be able to anticipate the future. That's what customers want as well. They want to be able to buy gas at a stable price, at a fixed price.
I'll answer in addition to that. The gas, as it's produced from the system, the gasification system, can be sold at the market price and is economical so that the project can be profitable. But in addition, in the United States and a number of other countries, and it's increasing in other locations, have an arrangement where green gas, if it's gas produced by a renewable process, gets a different price. And this started in California, and California has regulations that require the gas distribution companies to have in their pipeline a certain percentage of green gas or renewable gas. Right now the percentage is 10%, but it's going to 20% soon. And it's very difficult. There's not a source for 10% or 20% of green gas. So new technologies, especially hydrothermal gasification, is the favored technology to produce this green gas. And in order to encourage that, there is a special price for renewable gas, which is 400 to 500%, four times or 5 times the market price. So with that price, these projects can be very profitable, much more than the market price, even though the market price itself is economical. And you don't have to produce the gas in California. You can produce it any place and then nominate it or name it, give it a name that it's California gas. So it's an arrangement that provides very profitable operation for hydrothermal gasification.
Merci beaucoup. Nous allons
Thank you very much. We're going to thank the 6 of us. We're going to move on to the next round table, which is targeting demand.
Et donc,
This roundtable will be focused on those people who are asking for this gas, or talking about industrial players, and we're talking about public authorities. We're going to be listening to Flavie Bier, who works for the Karen, for the Saint-Nazaire conurbation. Also, we're going to be listening to Serge Chauffeur, who's project manager for Arkema, and also we've got somebody from Crystal Union, Benoit Lalizel. Well, thank you all for being here. Let me start off with Flavie Bier. You're also partner of the Gamma Project for Carling. Can you introduce Carling to us and explain to us why having this demonstrator project is interesting for you? What are the externalities you associate for everybody here? Thank you very much, and hello everybody. My name is Flavie Bier. I'm the head of the Karen, which is the Saint-Nazaire conurbation here, which is west of France on the Loire estuary. It's a conurbation that represents about 130 inhabitants, and the industrial basin is important, and it's a port system with a very interesting economic ecosystem, which is very much for this kind of project. Now, beyond this industrial and economic basin, there's a whole other environment that gives us a huge responsibility. We also want to protect the environment here. We've got a kind of ecological interest there, and we clearly have to protect the environment here. I'm talking about the estuary de la Bruyère, which is one of the most wetlands in France, and the whole coast strip with the estuary, which is a protected area. Why am I mentioning this? To understand why these projects actually exist. It's both to ensure energy transition, but it's also for climate reasons here, climate change reasons, and to fight against it, and also climate adaptations here. Coming back to the Gamma project here, why the conurbation got involved in this? I'm referring here to reasons. First one concerns what I mentioned just earlier on the climate goals, air and energy. Karen, together with the local authorities, came up with a route with a roadmap that fits in with the national goal here, and we're quite ambitious as far as 2030 is concerned. Of production, talking about 25% of energy would have to be renewable, which means that we have to multiply by 4 the current ratio as consumed by all the stakeholders of in this area. We need to reduce the greenhouse gases by 50%. The other idea is to focus on energy sobriety, which means using less energy. This climate plan is ambitious, and we consider the opportunities out there to produce renewable energy. Take stock of the situation, we actually realize we have to display great creativity. And in fact, we need to all think together between partners, public and private partners here for photovoltaic, renewable, and in gas, we're kind of limited as far as our area is concerned. Most mature technologies in France, it's methanization here, and anaerobic digestion, but in our conurbation, they haven't got that much in terms of feedstock. We've got one digester was opened recently, but it won't cover our needs for gas. So hydrothermal gasification is clearly something we are considering. I talked about us being an industrial basin, and this Nico Park, which is currently being developed here with a partner whose name is Idia. I'm not sure if they're present with us today, but they are with us from an industrial point of view to actually include this gasification project here. Am I moving the slides myself here? Yes. in terms of the pros and cons and the externalities here. Benefits here, I talked about two main reasons here. The goal here, but also the management. Here I'm taking my hat here to my colleagues. I'm also focusing on this aspect, and that's the water cycle management of wastewater here. Today, if we take the Carène, which is our Saint-Nazaire conurbation here, all sludge is composted here. But the challenges are becoming more stringent. Regulation is trying to improve what we call innocuity, a total safeness here, safety. Even if they've been composted, we need to make sure that they're no longer harmful, that they're totally harmless. Now, to provide the necessary incentive for those people who reject wastewater to really pay attention to possible pollutants, obviously, it's difficult to have this promise to be totally neutral, and that's where gasification offers a very interesting outlook in terms of treatment that may solve this issue in terms of disseminating solvents here, and that participates to the overall water, sludge treatment process here. Now, we talked about this project just earlier on. We're at demonstrator stage here. Now, why is the Carène conurbation interested in this here? The key principles are on the chart. We really want to demonstrate its feasibility, the technology, but it has a reason, has a definite purpose here. Okay, let's take into account everything, this promise, and what the feedstock. I mean, the sludge from the water treatment center, that's one source. But what can it offer solutions to other possible entrants here, other possible feedstock? We want to test what is possible. We want to test these feedstocks. And then in the end, this promise, this environmental promise, is it really there? Is it really feasible here? As a conurbation, if we want to be within this project, we want to be 100% sure. I mean, the water, once it comes out, can we remove the nitrate? Can we make sure that it comes back to the natural area without having a negative impact on the environment? Renewable gas, how are we going to reuse it here, because we manage public money here, taxpayer money here, this model that has to work. It faces other issues here. The market, will the market actually be able to make sure that this kind of project will be in place on time to meet the climate and energy goals? For the moment, we're not up to par yet. And then the other materials, mineral materials in particular, will be possible in terms of opportunities from a circular economy point of view. This side and being present in this industrial bassin will enable possible synergies. And we need to be spending 2 years to investigate everything. Now, here you can see
et d'économiser de l'ordre de 2000 tonnes d'équivalent CO2 en émissions.
Merci bien.
Merci beaucoup. Prochaine question pour Serge Schuffer. Donc, l'activité d'Arkema génère
leads to products that aren't easy to recycle and reuse. How can hydrothermal gasification enable, obviously, an improvement here? Well, my name is Serge Schuffer. I'm the site project manager for Arkema Carling here. Now, on that, in that area, there are various companies, including Arkema here. The platform is currently strongly developing here. We produce acrylic acid and its derivatives like esters and super-absorbing elements. We produce what we call heavy acrylics here. We talk about over 10,000 tons per year organic components here. Part is reused and produces steam here, and otherwise it is externally used with CO2 emissions, because we're talking about incineration, and it leads to logistic costs. Initially, we also manage treatment plants here. We are involved in a biological plant treatment here. We had some discussions with GRTgaz. We had the idea of going for hydrothermal gasification here, and we got in contact with various partners. And when we talked to different people, realized that our heavy products could be interesting for this technology. We've already had 2 lab tests on BUs and now other organic components here. We obtained excellent results here. We tested 2 other sub-products and byproducts with excellent results. This technique, this technology seems to be very interesting. Clearly, enables us to replace incineration. Obviously, the acceptance isn't great as far as incineration is concerned. On top of that, from a logistic point of view, it's a problem. It's not easy to find incinerating units that are willing to take our products. And the idea to be able to treat and process this on site is interesting. It started off at the Carlin site with an acrylic product, and today it has encountered a more general approach as far as the Arkema group is concerned. We focused on CO2. Obviously, for the coming years, we significantly want to reduce CO2 emissions. We've tackled the low-hanging fruit, a kind of conventional approach. Now we have to go beyond. This technique and technology will be disseminated throughout the group Arkema. I want to try and imagine possible use of this solution on other sites in the future. The next step is to see how we may have a pilot. We've done it for a couple of kilograms, and now we want to do the same for several hundreds of kilograms to make sure it really is compatible. And the goal, obviously, is to have an industrial demonstrator on site on that platform. And then over time, to put in place a treatment and processing solution that would avoid CO2 emissions by the incinerators, logistic costs. We could also value this byproduct, which may become methane, which could be injected in the network. We've got GRTgaz who are present, and we've got other players locally. The goal is clearly in line with what we've heard so far. The deadline is 2030. I don't think it's going to be possible to do things before 2030 as such. In 5 years, an on-site demonstrator, and in 10 years, around 2030, we can imagine an industrial unit on site, and probably other sites and factories and plants of the group may be concerned as well. For the moment, we worked with the TreaTech. The results are pretty positive here. Our components or compounds are a bit specific, not that easy to process, which may contain metal as well. So it may be interesting to be able to recover metals from the catalyzers here, and instead of sending it to incinerators. Thank you very much. It's on the floor to Mr. Lalizel, works for Crystal Union in the agri-food industry. That company generates a lot of byproducts as well. Here, same question for you. Why is gasification interesting for you? Why has it entered your scope of concern? And why hydrothermal gasification and not other possible approaches in terms of recovery and reuse? You're also working on FERNANDES here, talking about anaerobic units here. And linked to that question, what are the challenges for you when we're talking about hydrothermal gasification for the sugar industry, which you represent. Thank you for all these questions. Crystal Union, we are a co-op group. We're specialized in the transformation of beetroot into sugar and alcohol. Its activities require a lot of energy. Overall per year, we consume about 3 terawatt-hour, mainly as gas. De facto, this big energy consumption means that we have to declare our emissions within the ETS framework in France, and the goal is to decarbonate. We want to significantly reduce our emissions by 2030 and 2050. The challenge in terms of decarbonation is extremely important, and we haven't waited to today to start working on that. We have already got 25% of energy that comes from biomass, but we still got 75% to deal with. Now, within the process, we've got a lot of byproducts and organic byproducts. The sugar process, when you extract the sugar, we have byproducts such as pulp, which is the cellulose residue. We've got the foam, which is calcium carbonate with all the impurities. And then afterwards, we also have mollus or kind of treacle, which actually comes from beetroot, part of the sugar that is not crystallized within the process. In terms of the fermentation process, once it has been converted into alcohol, the yeast has been converted into alcohol, we'll also generate a byproduct called such as vinasse. For us, if talking about hydrothermal gasification, so HD, focusing a lot on the pulp, a lot of digesters have been put in place and work with pulp as the feedstock, and that's something that's been in place for a couple of years now. For 20 years now, we've been working on the methanization, on the anaerobic digestion of pulp and of vinasse. The problem is it yields to microbial issues here. We can't ensure perfect digestion, or at least we do so, but the dwelling times are non-satisfactory from an industrial point of view. Now, talking about the vinasses here, they are currently reused by through the salts they contain, mainly potassium here, and we sell them as a fertilizer based on what we call a normalization and salinization. Enables farmers to use them. Also, it's possible to sell them to organic farmers. When we consider all of this, well, we thought HG may be interesting for us. It's going to enable us to reuse and recycle the organic part and convert it into energy here. At the same time, we're going to be able to recover the salts that we can still use. And then on the other side, we can recover water, because vinasse is between 15 and 20% is water. So in fact, we can clearly see that all of this fits within this circular economy, which is crucial for us as a Crystal Union company. When we consider the quantities and the vinasse energy potential, we can ensure self-consumption and auto-consumption of the distilling unit. So we will be autonomous and independent from an energy point of view. For this hydrothermal gasification, we've already got our byproducts. We've got some expectations to be able to develop a technology at a kind of industrial level. And then afterwards, we should be able to, before that, we need to come up with and demonstrate waiting for a regulatory framework in France that could enable us to ensure the actual decarbonation of the syngas. The fact of producing a syngas and be able to use it to produce energy should enable us to decarbonate, and we need to be recognized as doing so. If we consider the biomethane point of view, it's a bit difficult in the current regulatory framework. And then specific subsidies could exist or support plans to limit the initial risk when developing these units. Thank you very much. We've got a couple of minutes left to take some questions, if there are any questions in the room. Take advantage of this time. It's the first time that we've got some industrial people here. I've got a question. Two industrial people who spoke talking about the product that they want to treat and process. What kind of concentrations are we talking about? Be it in the sugar industry or the acrylate, the organic part within your project. For Arkema, talking about the acrylics, 100% organic as far as most flow is concerned. So it's mainly softness. How can we inject it in water? And it's not always easy. We've got products that react to water. We need to fine-tune the actual injection. Otherwise, it's very interesting from a technical point of view, because we're just talking about organic components here. In the introduction, what I was saying, the presence of water in the process is crucial. However, if you take the feedstock, and the example speaks for itself, Arkema as a feedstock doesn't contain any water. The water is added to the system, but since the system is recycling the water, there's virtually no water consumption as such, and it works well. Closed circuit, and the conversion rate is extremely high. And we're close to, we're nearly reaching 100% with some of your feedstocks. To answer your question, for Crystal Union, we're talking about 3 to 4% mineral. The rest is organic. Mr. Chauffeur, did you want to react? Yeah, we've got the conversion for the initial trials at lab scale, of course. We're close to 100%. We're recovering very little mineral matter and water as an output. And that it can be recovered or reused, but the organic as a feedstock is totally converted otherwise. Thank you. Another question or not? Yes. Yes, hello. A question for Crystal Union. Can you give us some figures in terms of investment? If we consider a unit, you talked about becoming independent and autonomous in terms of producing the necessary energy. What kind of power are we talking about? And have you got an idea of your goal in terms of price, megawatt, etc.? That's not an easy question. Really? No, we haven't actually defined that today. Our goal is regulatory. We need to decarbonate. And afterwards, we're considering all the available technologies, all the possible technologies, as far as our byproducts are concerned. And afterwards, we're considering the investment costs, and if the technology enables to position ourselves and to be able to continue to, instead of continuing using fossil fuel. So today, the roadmap is to drop our CO2 emissions by 35% between now and 2030, and to continue dropping down to zero by 2050. And then afterwards, if possible, we want to become independent and autonomous from an energy point of view by valuing the byproducts. There are various routes we can go down. We've got methanization, so anaerobic digestion with the pulps, but also the effluents, the washing water we use for the beetroot. For the moment, we've got a more organic kind of, but we've also got nitrogen that is coming from the farming land here. And we've got also considering how we can value their content and reuse the organic component now to methanize that, and just to take fertilizing elements then. The cost today, we don't really know. We haven't come up with that as a goal as such, as an objective. Thank you. I think we got another question, or not? Yes. Hello, my name is Pierre from SUEZ. Question for Karen. The size of the project, you presented the project of the Saint-Nazaire renovation. We were talking about, I don't know, recycling and reusing the feedstock. Now, what was your key motivation to move on immediately onto this size? Because it's a big, you've done it at a big scale. Well, the initial motivation is to say, well, we really want to be at the initiative of this project at a demonstrator phase, and then afterwards move on to the industrial level. What drove us rapidly, well, was to actually, I mean, a demonstrator, you need quantity. When you look at the figures, we thought we might as well envisage something big here. Now, if we want to cover the full sector and the industry, considering all the possible benefits here, and we could clearly see that we had a lot of sludge to deal with. And we thought, well, we would obviously be beyond, way beyond the ton or two here. So we knew that we had to think big. To demonstrate the idea was to test other feedstocks here. So we thought, well, we're going to continue this study, and we're going to consider an additional financial layer. And if the project shows all these benefits, it will then be able to move on to a sustainable level, industrial level, and be a benefit to the whole area. That was the main driver. As mentioned earlier, the project hasn't been finalized yet. We're still in a study phase. But anyway, this is the goal we are targeting today. Thank you very much. I think we got a last question. Okay, well, fine. In that case, thank you all three. Thank you all for coming. Last word.
Oui, merci beaucoup à vous tous. Je suis très positivement enchanté qu'il y avait.
Thank you very much. Thank you very much. It was very. I was glad to see that there were so many people. Last year, at the same period, at the same date, we were the post-COVID. So, well, we decided to do the these conferences despite of that. But now, I think we are very happy to see that we are back to normal life. And well, I think it's glad to have heard to all those informations that we had this conference, and we could get to know more of the different aspects of this technology. I think these aspects were very interesting. We have had a very interesting point of view and approach. We have worked a lot and it was very, very intense work. We have presented all the different activities of the developers, and well, we have also seen the different industrial possibilities. So, well, these are changing the current situation because the war in Ukraine has changed many things for all of us in the sector, and our industries are suffering a lot because of the increase of the energy costs and energy prices. So they are concentrated into decarbonization, and they are seeing that they have some resources that can be hidden in their waste. So this is why we think that maybe hydrothermal gasification will be able to offer to solve this issue and to offer some solutions. So that was very interesting. Thank you very much for being here, for being so many people here today with us. And I hope that maybe next year we will present some new discoveries as well. Thank you very much.
Ah oui, oui. On m'a coupé.
Okay.
Je pourrais avoir juste...
Yes, I would like to add something.
Encore avoir le micro, oui,
Is
merci.
that possible? Yes, I just wanted to thank the organizer of this event, Paul Stewart. He allowed us to organize this conference and to have many people connected in remote connection. So thank you very much. Thank you for all those efforts. Thank you.